All right, folks. Thank you. Thank you. It's been a long day, so thank you for staying here and staying through this talk. So I will be following Jason's overview on our IaaS infrastructure and building on top of the IaaS infrastructure by our IaaS team and Alibaba Cloud. We are building the next generation cloud-native database system for Data+AI applications to support our customers to transform from data to intelligence. So the key message I want to get across from my talk today is to upgrade our ApsaraDB cloud-native database systems to a one-stop multimodal data platform powered by Data+AI technology and empower our customer to build Data+AI applications. So this is the overview slide to give you a key takeaway message. So the idea is that if you think about the revolution of database systems from back in the old times to what it is nowadays, the key idea is that, or the key observation, I should say, is that from managing traditional structured data, database system has evolved into managing way beyond structured data, from structured data to semi-structured data, all the way to unstructured data, especially powered by large language model. Large language model enable us to understand the semantics of any form of unstructured data. Basically, you can do embedding and transform any form of unstructured data to a vector representation so that it's quote-unquote structured. For example, represented by billions of vectors in high-dimensional space. So this gives us enormous opportunity to manage the data landscape in a way that's never done before. So the key idea is to upgrade our data management service product called DMS to a multi-modal data management platform. And together with DMS key capability that we have released this morning, we call OneMeta and OneOps. OneMeta is to provide a unified metadata management across different environments, different database types, different data instances. And OneOps is to connect and integrate DataOps and MLOps so that from ETL to feature engineering to model serving, all provided and unified by DMS. Then DMS alone is not enough. You need different engines to focus on different vertical segment to provide specific functionality for that vertical segment. For example, transaction processing, analytical processing, multimodal indexing, and so on and so forth. So based on DMS, OneMeta, and OneOps, we push out this idea of DMS plus X, so that DMS combined with Lindorm, our multimodal database, enable you to manage and index data for AI search, for autonomous driving scenarios. DMS plus PolarDB and ADB enable you to do ETL and RAG, and so on and so forth. So I will, in the next few slides, I will dive into the details. But this is really the key message that I want you to take away and get across from my talk today. Now, let's dive into the details. I briefly talk about DMS, OneMeta, and OneOps. Here is the detail I have promised. So OneMeta is to provide a unified metadata management across different database types, across different database instances, and across different even infrastructures, meaning that it can manage database instances on Alibaba Cloud, at the same time integrate metadata from another environment. For example, can be your own IDC or even another cloud vendor infrastructure. This is really needed by customers. For example, customer is in the middle of migrating from another cloud to Alibaba Cloud. Hasn't been 100% done yet. There is live instance running over there. There's some live instance running on the IDC for compliance security reasons. You can have data instances across different environments, but you really want to manage those metadata in a uniform, integrated manner. DMS and OneMeta give you that capability. And DataOps, ETL, RAG, feature engineering, these are the buzzword nowadays, are essential components for building Data+AI applications. With OneOps, we are able to integrate all those data pipelines, those very complex, very details-oriented data pipeline into one place so that it's easier for you through a notebook-like development environment. With OneMeta and OneOps plus different engines down below, like I demonstrate here, you are able to build what we call data mesh. So for example, DMS plus PolarDB ADB for transaction and marketing ops. DMS plus Lindorm for transaction and intelligent search. DMS plus ADB and our RAG platform, we are able to do one-stop enterprise level RAG application deployment. So in summary, DMS OneMeta OneOps enable us to do DMS plus X, as can be our own database engine or customers' own database instances. Enable customer to build in DBML in a much more efficient manner, and enable customer to deploy enterprise level RAG development and application, and to build new form of AI-driven search on multimodal data. Next, I will dive into some of the details on each of the X. Remember, I talked about DMS OneMeta OneOps, DMS plus X. X is PolarDB, ADB, Lindorm, or RDS, or customers' own database instances. Each X provides a key capability for a particular vertical segment. So the key idea, before I dive into the details, you should. I really want you to take away this key message. Cloud computing, our mission is really to build data center as one single giant computer. How we do that is through disaggregated resource pool. So we disaggregate storage and computation. In last year, from last year to this date, and we are still very heartily working on this, we are disaggregating in the compute node, we are further disaggregating CPU core and memory so that we have shared storage pool, shared memory pool, shared stateless compute pool. And we do this for our database systems so that our database can offer the best in class elasticity and high availability, as I will demonstrate to you in the next few slides. So first thing we are able to do with this three-layered disaggregated architecture is serverless. The first generation cloud native database does something to the left. What we are able to do with PolarDB, with the latest version of PolarDB, is something to the right, so that we can allocate resource, and resource being memory, compute, and storage in any combination of you want. And in second level, allocate resources according to your workload at that very moment. And we're able to do this on one machine, cross machine, scale out, scale up, scale down, you name it, in seconds, without any interruption to the transaction processing or analytical processing and so on and so forth. So this is really the best-in-class serverless capability you can find on any cloud. And in addition to serverless, on the three-layer disaggregated architecture on PolarDB, we push out the one and only one worldwide multi-primary cloud-native database service. Okay, you can only find this on PolarDB on Alibaba Cloud. So we all know cloud-native database through disaggregated storage and computation offer you one read-write node, many read-only node. However, with these three-layer disaggregated architecture in the latest version of PolarDB, we are able to do multi-primary, meaning any single node in PolarDB is able to handle both read and write, can do both transaction processing, and even beyond that, because with this architecture, we can call up, allocate a new compute node that's dedicated for HTAP, dedicated for AI processing, for model serving, and you name it, because it's multi-primary. All the compute nodes are stateless. The state is persist and consist by the shared remote memory buffer pool. We are using RDMA for the current technology. We are using CXL for the next generation. Even with the current RDMA technology, our shared memory buffer pool is able to scale up to 100 terabytes for a single instance. Of course, the shared memory buffer pool is multi-tenant as well, so the cost is fairly low. We use this feature to support one of the largest game release on Earth for miHoYo. In 1 second, 50 million users, gamers, came online, no problem. Serverless, multi-primary, very easy to handle this case. Now, a lot of customers ask us about cost efficiency. And the way we address that is to work with our ICE team to do not only software level innovation, but do software hardware co-design innovation. For example, we have our own ARM chip called Yitian, and we have our specially designed transparent compression disk that has an ASIC. I talked about this last year, but last year we were using FPGA. This year we replaced FPGA with ASIC so that the cost is dramatically reduced. At the same time, it provides transparent compression and decompression whenever a data block is pushed down to the storage layer from the kernel. All this is done without using any CPU cycle, without using any kernel processing. So you almost get this for free. With all this technology, you get 3x compression rate and cost reduction without any performance degradation. And in our cloud-native data warehouse, we talk about ADB every year. And ADB is an MPP analytical database, similar to Teradata, similar to Terraform. Teradata. What it really is a cloud-native version of Teradata and a Greenplum. That's the way you think about it. And the key message I want to get across is similar to what we are doing with PolarDB. In ADB, we are pushing to this 3-layer disaggregated architecture as well, so that for analytical workload, you get the best serverless and the elasticity capability that you can find out there. Of course, there are a lot of challenging issues to be addressed. In addition to being elastic, being serverless, how do you do isolation for multiple different tenants, for different kind of workloads, for online interactive workload, and for batch offline processing? And the other thing is working with our ICE team, like Jason has introduced, for example, OSS. We are leveraging OSS capability, and so that we label data in ADB through intelligent algorithms, classify them into hot, warm, and cold different data layers. For cold data layer, we push them to OSS. For warm data layer, we push to ESSD. And for really hot data, we cache in memory, of course, disaggregated memory pool, so that we can really reduce your cost while maintain computation analytical efficiency. And working with hardware vendors such as NVIDIA's GPU, we are also building vectorized execution for all the operators we have. Leveraging GPU's same instruction multiple data capability, we are able to bring vector execution to another level. Here is a customer use case for that. And yesterday's keynote, there are 2 panels talking about, in my opinion, bringing intelligence to the physical world, autonomous driving vehicles, and also human form robotics. In each of those cases, of course, there is huge demand for the fundamental capability of large language model for intelligent decision making. But at the same time, this wave of AI is driven by data, in my opinion. So data is really, really important, especially for those Internet of Things type of applications, robotics applications. The key challenge over there is to manage multimodal data. In addition to structured data, how do you manage text data? How do you manage log data? How do you manage machine-generated data? So Lindorm is our answer for that. Lindorm started off as a white KV table, kind of like HBase. But in addition to that, we add vector indexing capability. We add full text indexing capability to it. And we add spatial geo data indexing capability to it. So it upgraded to a full-fledged multimodal database that gives you one-stop multimodal data platform. In fact, 65% of China's new autonomous driving vehicles brands are running on Lindorm. And 60% of AI info startups, such as Moonshot, are running their AI search on Lindorm. Here is one specific example. As you can tell, we are pushing for this vision as well in Lindorm, meaning 3-layer disaggregated architecture. Of course, PolarDB is on this direction. PolarDB has gone the furthest. ADB and Lindorm is following up. But that's our vision, where we are going. And we talk about the design of Lindorm, the storage engine, the indexing for multimodal support in a VLDB work. And here is one specific example. This car called Zeekr is actually a very popular car, a very popular brand in Zhejiang province, from this very province that we are located at. And all the cars, over 300,000 cars in Zeekr are running on Lindorm, leveraging the multimodal data processing capability. And of course, a lot of our customers are using open source solutions. For that, one of the key products is RDS. In RDS, we are really just taking RDS to another level by fully integrating with our ICE products, what Jason has been talking about. For example, integrate RDS with OSS and EBS so that you have layered data architecture, data storage and processing architectures, and using E10 chips and a CIPU that Jason has introduced. By doing so, we are able to improve the cost performance trade-off by 150% or even more. Here is a customer success story, which is one of the largest internet companies in China, in the gaming industry, by the way. I want to bring you to a major release. In addition to DMS, OneMeta, OneOps, DMS plus X, and all the stuff I talked about for PolarDB, ADB, Lindorm, I do want to bring your attention to a very important release in Tair. Tair is our KV product similar to Redis. You all know Redis, right? Just like in the old internet age, there is a popular product called Redis. I believe in the next generation AI-powered online serving applications, there will be a similar KV cache service for large language model inference and the AI model inference, because caching is a common enough component. If it's a common enough component, it should be abstract out and become a multi-tenant SaaS service, just like Redis does for LAMP, Linux, Apache, PHP, MySQL, right? So we are doing that for Tair. We are releasing a serverless KV large language model inference accelerating service, fully integrated with NVIDIA's GPU inference card, leveraging NVIDIA's TensorRT large language model framework to provide this PD prefill decode separation, caching, acceleration for large language model inference. Last but not least, people care a lot about high availability and disaster recovery. In ApsaraDB, we offer you a wide range of selection. Each option is a trade-off between cost and RTO and RPO. The key message I want to get away is that, of course, from cost point of view, you want to choose a single AZ product form. But if you choose a single AZ product form, you have to be prepared for AZ level disaster. In that case, your service will be disrupted. And even in the worst case, you may risk the losing of your data. The good news is, if you choose ApsaraDB, even if you choose single AZ deployment, we guarantee you RPO equal to 0, because for all single AZ products, we offer a cross-AZ code data backup, so that in AZ level disasters, should that strike, your service will be interrupted, but your data and your instance will be back online if you allow us to do PITR, point in time recovery, in another available zone. On the other hand, if you choose a cross-zone, 2-zone HA architecture, or even a 3-zone HA architecture, then you get minutes level, even seconds level switchover when disaster strikes. So it's all, the choice is in your hands. Your data, your instance, if you choose ApsaraDB, is in safe zone. That's the key message I want to get across. In addition to our own products, we have we are a very open platform. We have integrated very popular third-party vendors such as MongoDB, ScyllaDB for the Doris community, and the CK. In fact, Alibaba Cloud has been named as the most valuable partner for MongoDB 3 years in a row. Lastly, I will really quickly go over some best practice. I will skip this. This is talking about DMS plus ADB, DMS plus X, DMS plus ADB, and Tongyi to build a one-stop RAG solution. And Jason mentioned this, I re-emphasize this, the Summer Olympic Games in Paris runs on ICE, runs on ApsaraDB. And in fact, this is an example where we provide high availability. We use London and Frankfurt, two regions to provide RPO equal to 0 and RTO less than a minute. I will skip this. I do want to talk about the case of Moonshot. Moonshot is an AI native app powered by large language model, very popular in China, and they're moving to overseas market as well. Moonshot is using large language model to build a new generation AI search experience or AI assistant. And for that, they need to index and manage large-scale multimodal data, text, KV, vector, you name it. And using Lindorm, we are able to support Moonshot to bring next generation AI assistant, AI search to their users, one of the fastest growing AI native app in China, okay? And the last one is really to state that Alibaba Cloud ApsaraDB is being recognized in worldwide stage. For example, I just mentioned one thing. We're the only APAC database vendor and cloud vendor being named by Gartner as a cloud DBMS leader in the Cloud DBMS Magic Quadrant 4 years in a row. So that's really my presentation today to bring you back to 10,000 feet. The key message, transforming data to intelligence. Cloud native database is moving on to one-stop multimodal data management, and ApsaraDB is your choice for building data plus AI application. Thank you.